we will start with standard 8 quadrilaterals. Here we are going to understand quadrilaterals. What I mean by quadrilateral is quad, 4, lateral, sided, 4-sided figure. Okay, but I have an example here where I have A, B, C, D, which is a quadrilateral.
Yes.
Similarly, I have one more quadrilateral which is P, Q, R, S. Yes,
Yes.
the sides are different in sizes. Still, it is a quadrilateral because it is a 4-sided figure. And I have one more quadrilateral which is again a different one. And again, what should I have? 1, 2, 3, 4. I have one more quadrilateral, a 4-sided figure, which is also represented like this. Now, all these are same. If you say, definitely it cannot be same. When I say it cannot be same in two ways. One, the length of those sides. Not all the 4 are the same. If all the 4 sides are same, it is going to be called as square. So I have a quadrilateral which I call this as a square when I have all the 4 sides are same. And I have a quadrilateral where only the opposite sides are equal. I call this as rectangle. And I have a quadrilateral which is a 4-sided, but this time the opposite angles are going to be the same. And I call this as parallelogram. These two are same and these two are same. And not only that, these two angles are same and these opposite two angles are same. But check in this case, 1, 2, 3, 4. All the angles were same in square and all the angles were same even in the rectangle. But in this figure, not all the angles are same. Only the opposite angles are same, and henceforth we call this as parallelogram. Similarly, there is a parallel side. There is a parallel side which is 1 and 2, but the other two opposite sides are not parallel. It is not a square, not a parallelogram, not a parallelogram, not a rectangle, but this time I call this as trapezium. Let me name them. This is trapezium. This is parallelogram. And this is a rectangle. And this is a square. So these are quadrilaterals. And I showed you a figure here which is nowhere similar to what we see in the other. There is something called concavity. We call this as concavity. Let us see more about this. Okay, what's this concavity or convexity of a quadrilateral? I say all these quadrilaterals are closed figures, but I find a small difference. What is it, sir? I have the first side and the second side and the third side, but I have sides like this. But I have 5 sides. No, not about this. I am not talking. 1, 2, 3, 4. Let me say a 4-sided figure here. This represents a cave. This is concave. So therefore this is concave polygon. Oh, I stumbled upon a word called polygon here. Then let me tell you what a polygon is. A polygon is a closed figure where all the 4 sides are equal. Here I call it as a square. That means a quadrilateral is a polygon for only square. Quadrilateral is a polygon and that polygon is nothing but a square. That's all. Understand the point now? So here I showed you something called concave and therefore it is a concave polygon. Then what is a convex polygon, sir? A normal figure, this point is a convex polygon. This is a convex polygon because when I have a center like this, I have a convexity lying like this, okay, which is closed, but here in this case it is cave. In this case it is not a cave. When I move to this polygon, it is a cave. I am standing before a cave and therefore it is a concave polygon. And here it is a convex where I can touch. My touching point is going to be the outward circumference, but here my touching point is the inward circumference. So this is concave and this is convex polygon. How is it? I have a quadrilateral of this type, A, B, C, D. Then what's a diagonal, sir? Any line drawn to the opposite vertex, that is A to C, there is a possibility that I can draw a line, and that line finds to be a diagonal of a figure. And is there any other one? Yes, there exists between B and D. So BD is again a diagonal which is of second. So any quadrilateral will possess two diagonals, and this can happen only in convex quadrilaterals. This can happen only in convex quadrilaterals. Okay, I have a figure which is a square. Do I have a diagonal? Yes, I have a diagonal. I have a rectangle. Okay. Does it have a diagonal? Yes, it has a diagonal. Okay. And I have a parallelogram. Okay. 1, 2. This is a parallelogram. Does it have a diagonal?
Yes.
Yes, I have a diagonal 1 and the diagonal 2. We talked about polygons. Let me have a three-sided figure first. What's a three-sided figure? 1, 2, 3. What's a three-sided figure? The three-sided figure is nothing but a triangle. I call this as a polygon which is regular when sum of all this angle in the triangle is what? 180 degree. Sum of all the angles in a triangle is 180 degree. And if I call this triangles as ABC, what I mean is angle A plus angle B plus angle C should be 180 degree. Okay, if I say all the three angles are equal, when I say all the three angles are equal, how do you see? 3 times angle A is 180 degree. If angle A is equal to angle B is equal to angle C. If I have like that, then angle A is how much? 180 degree divided by 3, and angle A should be what? 60 degree. Means I call this as a regular polygon if all the angles present in a triangle are 60 degree. Okay, not only that, and I find angles will have equal vertex too. Equal angles have equal vertex 2, and therefore it's a triangle which is a regular polygon. And so I have 1, 2, 3, 4. Let me call this as AL, M, N. What should be the sum of all these angles? I have angle K plus angle M and M plus angle N. What should be their sum? 360 degree. What is their sum? 360 degree. If it is 360 degree, I write 4 times K an angle. When I say all this angle K is equal to L is equal to M is equal to N, when I say that, it is 360 degree. And what is K? 360 degree divided by 4. And how much is this K? It is 90 degree. I call this a regular polygon if I have all these angles equal to be 90 degree. Understand the point?
Yes.
I have a quadrilateral here with angles 90 degree. And here in this case, this can be a regular polygon if and only if what?
The vertex should be
Right. AL should be equal to LM, should be equal to MN, should be equal to NK. When all these sides are equal, only then there is a regular polygon. Understand the point now? So name this regular polygon. It's a square. It's a square. Then another example of a quadrilateral is what? Having all the angles 90 degree. It's a rectangle. But opposite sides are equal. So what happens here? That becomes irregular. Understand the point now? Okay. You came to know about tri. You came to know about quadra. Why can't you check with penta? Pentagon. Shall we? Just fix this up. Find the angle, measure x in the following figures. Shall we try this?
Yes, sir.
Find the angle, measure of x in the following figures. Let me have question number 6. 1, 2, 3, and then the 4. We have 50 degree here. I have 130 degree here, and I have 120 degree here, and I have x here. Yeah. Now my question is, why this x is equal to 60 degree? Can you tell me? Why this should be 60? What could be the reason? Let me put it like this. X plus 50 plus 130 plus 120 is how much? Should be what? If this is 60, okay, 120, 150, 250, 300, and this x should be 60 degree. So what? Sum of all the angles in a quadrilateral should be 360, and you have 50, 130 and 120 in the angles for the different vertices, and one of the answer is x, and that should be 60 degree. 70 x 60. So we have 70 here. Yeah, we'll go for that. And then I have a 90 degree here, and I have x here, and here I have 60 degree. Yeah, come on. What can be done for this? Find for the x. If I say this as 90,
that side is also
correct, that side is also 90. So the opposite side of a perpendicular line or opposite angles of a perpendicular line are going to be 90 each, and I have 70 plus 60 plus 90. What's x?
220 total.
360 minus 70
140.
plus 60
That is maybe 140.
plus
That is
90.
140.
How much is the total sum? Come on, tell me.
140.
360
Sir,
minus
220.
90,
220.
150, 220. Okay. Now you tell me.
140.
So
140 days.
140. X is equal to 140 in this case. Very good. So sum of all the internal angles of a quadrilateral is going to be 360 degrees. Then what about the triangle? 2, 3, 4, 5. This was 70 degrees. This was 60 degree. These two is supposed to be x, and this was 30 degree. Okay, let us work on this. I had a figure like this. So sum of all the angles. This is going to be 110. This is going to be 120. Now let me add this. 2x plus 30 plus 110 plus 120 should be equal to 540 degree. How much is this? 2x plus.
Most probably.
So we have completed this sum with 2x plus 30 plus 110 plus 120, where all these sums should be 540. We got 2x plus 260, which is going to be 540. 2x is equal to 540 minus 260, which we got 2x is equal to 280, and x is equal to 280 by 2, which is x is equal to 140, and that's x. So with this, try to do the exercise 4.1. We'll meet in exercise 4.2 next time.